This is the group activity for Math 117, lesson 10.3. Number 1, imagine that your parents invested $5,000 at 6% APR in an account earning compound interest on the day you were born. So that's a key word there, compound interest. Use the formula to calculate how much money the investment is worth for each of the given numbers of years. Okay, so this is a formula for compound interest that's earned yearly. So I am going to put in a 5,000 for P. My R is going to be 0.06, and then I'm going to put in all these different values of T. So let's write this out. This is P is 5,000. 1 plus 0.06 to the T. And now I'm going to make T 0. So I have 1.06 raised to the 0, which is 1, times 5,000, which is 5,000. So this makes sense that the day you were born, there's $5,000 in your account. It was just deposited. Now I'm going to do 1.06 to the 10th, and I'm going to multiply that times 5,000, and I get 8,954. I'm just going to go to the nearest dollar. And then for 20 years, I'm going to do 1.06 raised to the 20th. Multiply that times 5,000, and we get 16,035. And I'm going to fill in the rest of these using 30, 40, 50, and 60 as values for T. Okay, I have filled out the rest of the table. Now we're going to plot the points on the grid below. So 0, 5,000, about right there. 10, almost 9,000. 20, 16,000. 30, 28,000. 40, 51,000. 50, 92,000. We're almost at 100. And then 60, 164,000. It's about right up there. So we see we have this curve that's increasing and bending upwards. Like that. Let's say that instead your parents invested $5,000 at 6% APR in an account earning simple interest. So the same parameters as above, but it's simple interest instead of compound interest. Use the formula for simple interest to calculate how much money the investment is worth for each of the given years. I think I'll do this one in another color. Okay, so my future value is my present value, 5,000, times 1 plus 0.06 T. Okay, and I'm going to put in different values of T. If T is 0, 0.06 times 0 is 0, 1 plus 0 is 1, 1 times 5,000 is 5,000. So I put 5,000 in here. And then if T is 10, I'm going to do 0.06 times 10, which is 0.6. And then add 1. $1.6, and then multiply times 5,000. And we have 8,000. Okay, so after 10 years, $8,000. After 40 years, I'm going to do 0.06 times 40, add 1, and then multiply by 5,000. And I get 17,000. And after 60 years, I have $23,000. Okay, so if I plot these, I have 0, 5,000. We start with the same amount. After 10 years, I have 8,000, which is just a tiny bit less than what I had with compound interest. After 40 years, I have 17,000, which is way less than what I had with compound interest. And after 60 years, I have 23,000, way less. So this ends up looking like a line that grows much slower than the compound interest. So the greater earnings is definitely compound interest. Number 4, find the future value of a CD if you invest $875 for a term of 7.5 years at the local bank, which is offering a CD that pays an APR of 6.75% compounded in these different amounts. Okay, so I'm going to write down the formula for compound interest. So, future value is present value times 1 plus R over the number of compoundings per year times NT, raised to the NT. Okay, so I'm investing $875. My interest rate is 6.75%, so I got to change that to a decimal, 0.0675, divided by the number of compoundings per year. If I compound twice a day, well, there's 365 days in a year, times 2 times a day is 730 times per year, raised to the 730 times number of years, 7.5. Okay, so now I'm just going to crunch these numbers on a calculator. This is 875 times, I'm going to do what's in these parentheses, so I have 0.0675 divided by 730, and I get a decimal. I'm going to add 1 to it, and I have 1.000092466. That's all the decimals my calculator can hold. And then I'm going to raise that to the 730 times 7.5. Which is 5,475. So that's 875 times. Now the order of operations says you have to do the exponent before you do the multiplication. So I'm going to raise this number to the 5,475. And I'm not rounding this number at all. I'm going to carry all the decimal places my calculator can. Maybe even store this number in using my calculator's memory function. Okay, and I end up getting 1.659, which is a little bit rounded. I'm going to write it down rounded as a way to keep track of my work. But when I do this multiplication, I'm going to this number is in my calculator right now, and I'm just going to hit times 875. So it's going to use the full decimal version of this number. And I get $1,451.64. Okay, so when you compound more often, you make more money because you earn interest on interest. So the more frequently you add in your interest to earn more money on, the more money you're going to make. So it seems like if I went from compounding twice a day to compounding 24 times a day every hour, then I would make a lot more money. So let's see what happens. So I'm going to do the same calculation. I'm just going to replace the n with a number that represents every hour. So 875 times 1 plus 0.0675 over, okay, the number of compoundings per year, well, I have 365 days in a year times 24 hours in a day is 8,760 compoundings every year. So I just have my calculator do this calculation. Make sure you're careful to follow the order of operations. Careful not to round until the very end. And this comes out to $1,451.67, which is only 3 more pennies than we earned by compounding twice a day. So compounding every hour does not get you very much more. What if we compound every minute? So I'm going to take my future value, and that's equal to 875 times 1 plus 0.0675. The number of compoundings per year. So that's how many minutes are in a year. So I'm going to say, well, 365 days in a year times 24 hours in a day times 60 minutes in an hour. And I get 525,600 minutes. And then we raise that to the 525,600 times 7.5. We have a calculator do this calculation, and we get $1,451.68 if you round up. And so by going from 24 compoundings a day to 60 times 24, which is 1,440 compoundings a day, we only made one additional penny. And not even really, I rounded this up. We made less than a penny. Are these future values smaller or greater than the future values in 5, 6, 7, and 9? Well, if you go back and look at the demo for this lesson, numbers 5, 6, 7, and 9 had you compound annually, quarterly, monthly, so less frequently than these examples. And what we just came out with were greater values. You make a little tiny bit more money each time you do an additional compounding, up to a limit. Okay, up to a limit. Eventually, like if you start trying to do this every minute, you aren't going to make much more money, if any at all. Number 5, compute the APY on an account that begins with $835.25 and grows to $932.80 over the course of 1 year. Round to the nearest tenth of a percent. Okay, so this is really, APY is just percent change over 1 year in an account. So percent change, remember from our previous lesson, is just the difference, the total amount of change. So we figure out how much did our account change by, and then we want to divide by the original amount, $835.25. And this will give us our percent change, which is what APY is. Okay. And this comes out to 0.11679, and that's 11.679%, but they said to round to the nearest tenth of a percent, so we'll say 11.7% is our APY. And then for number 6, we want to use APY to compare investments with varying rates and or number of compoundings. Which of the following 3 investments is best? So hint, imagine you're investing $100 in each account for 1 year. So here we have continuous compounding, which is, the formula for that was future value is present value times e to the RT. So I want to figure out my future value. My present value, I'm going to invest $100 at 0.067%, 6.7%, which as a decimal is 0.067 for 1 year. We'll see how much I make on this account. It comes out to $106.92. Okay, part B, we're going to get a slightly higher interest rate, 6.75%, but we're going to be compounding monthly, which is less frequently than continuously every single possible moment. So higher interest rate, fewer compoundings. To compare it, look at what happens to $100 in 1 year. So my future value will be $100. Actually, let me write down the formula for compound interest. P times 1 plus R over N to the NT. $100 is my investment. My interest rate is going to be 6.75%, so I put in 0.0675 over 12 compoundings per year to the 12 times 1. So I just want to know what this makes in 1 year. Put it in a calculator, and we get $106.96. And then finally, 6.8% APR compounded quarterly. So future value is present value times 1 plus R over N to the NT. And my future value is going to be 100 times 1 plus 0.068 over quarterly is 4 times per year. And let's see, this comes out to $106.97. Okay, so this one is the highest. This is our best option.